Good morning, friends. My name is Ashish, and I'll be giving a demo on application of logarithm in solving roots of a quadratic equation. We will be taking an example and apply the basic principles of logarithm in finding the roots of a quadratic equation. So here is the question, like find the number of solutions of log x minus 1 to the base 4 is equals to log of x minus 3 to the base of 2. We have four options here and we have to calculate the correct option. Now we can see from the question itself that the left hand side and the right hand side of the question asked has the different bases. The left hand side has the base of 4 and the right hand side has the base of 2. So for solving this kind of questions, we have always have to take the bases as common. Then only we can equate the argument part of the log. Now let us take log of b to the base of a as x, and the exponential form can always be written as a raised to x is equals to b. So on squaring the both sides and taking the log on both sides, we get as x log a square is equals to log of b square, and we use the basic formula of log a raised to n is equals to n log a here. So we get as x is equals to log of b square by log of a square. Now we can see from here that as per the change of base rule in basic principles of logarithm, we can always write log of b to the base a as log of b by log of a, where the basis is common, that is c. Now, as per the previous deduction, we can write log of b square by log of a square as log of b square to the base of a square, which is equals to x. So from equation number 1 and equation number 2, we can write as log of b to the base of a is always equals to log of b square to the base of a square. So we have a question like log x minus 1 to the base 4 is equals to log of x minus 3 to the base of 2. Now the right hand side of the equation we can write as log of 2 log of x minus 3 square to the base of 2 square, that is log x minus 3 square to the base of 4. Now we can see from equation 1 can be again written as log of x minus 1 to the base 4 is equals to log of x minus 3 square to the base of 4. Here the base part of both the left hand side and the right hand side is equal, hence the argument part, that is x minus 1 and x minus 3 whole square, can be equated. So on equating these terms, what we have, like x minus 1 is equals to x minus 3 whole square. So on calculating this particular equation, we get as x square minus 7x plus 10 equal to 0. So this is actually a quadratic equation of the form x square minus sum of roots into x plus product of roots is equals to 0. So when we try to calculate the roots of this particular equation, we get as x minus 2 into x minus 5 is equals to 0. Therefore x is equals to 2 and x equals to 5 are the two roots of the equation number 4. So now in questions of log, we always put the value of x in the question asked and we confirm the solution of the equation. So when we put the value of x is equals to 2 in the equation number 1, we get as log 1 is equals to log of minus 1. Since the log of any number is not defined, so x equals to 2 is not a solution to this particular question. And when x is equals to 5 is we try to put in our question asked, we get as log of 4 to the base 4 is equals to log of 2 to the base 2, that is 1. So x equals to 5 is the solution of the particular question. So we now can conclude that we have seen that only out of the two roots of the equation, only one root holds good to be the solution of the equation, that is x is equals to 5. So this equation, that is log x minus 1 to the base 4 is equals to log x minus 3 to the base 2, has only one solution. So our answer in the option is B, that is 1. Thank you.